All right, the second question we're going to be looking at here is in terms of the fluid flow that we're dealing with. So I always start here with mass fluid flow because it does reduce to volume fluid flow. The idea is we have a hose in which half its cross-sectional area is cut off while fluid is flowing through it. So up here at the top, we have our little diagram for it. Basically, our cross-sectional area has been reduced to about half of what it is before. However, there is still fluid flowing through from one end of the hose to another, like so. Right, and so your goal is to figure out how much greater will the velocity at one end be when compared to the unobstructed end. So in other words, what we're going to compare here is we're going to compare the speed here, which I'm going to call v, to the speed or velocity at the other end, which we'll call v prime. Now, to figure this out, we're going to look at our fluid flow equation. Our fluid at flow at one end must equal to the fluid flow at the other. And then we're going to use that to compare all of our different things to figure out what the relationship between these velocities is. Now, to start things off, we're going to assume that's the same fluid going through it. If it is the same fluid, it should have the same density, because we're going to assume that our fluids are incompressible. So right away, you can get rid of these densities, because they are common to both sides, so they can't be divided out. Now, next up, what we're going to do is we want to compare these two. So the best way to compare things is to simply have one be equal to some constant times the other. So what I'm going to do here is we're going to move a prime to the other side. This is going to leave us with v prime is equal to a divided by a prime times v. And so if we have this a divided by a prime here, we can very quickly figure out how the two velocities are related. Now if you take a look at this, I have my regular area and my restricted area. And what I've been told is this one here is half the other one. What that means is a divided by a prime needs to be equal to 2, because this area is twice this area. This lets me relate them together. I can say v prime is equal to 2 times v. And so what that basically means is if you're taking a look at the fluid flow, the fluid coming out of the restricted end of the pipe is going to be twice as big or twice as fast in terms of its speed or velocity as the fluid that's coming in the wider area of the pipe. And that's it. These are typically all just done by comparing the fluid flow rates and canceling out things that are the same. All right, so we can say this is true because we're told that the half of its cross-sectional area is cut off. So we only have half of what we start with.